Hi guys, I'm Laura Waller, and today I'm going to go over how to do a C1, V1, C2, V2 problem. So you are going to come across these when you have a patient, for example, that needs dextrose added to their fluid bag. Let's say their blood glucose is low and the doctor says, hey, I need you to make that a 5% solution. The patient might have a full bag, it might be half empty, who knows, and you'll have to be able to figure out that math. So we're gonna be using dextrose 50%, and then we have a whole liter of lactated ringers. So let's start with the math portion. That just kind of gives you a visual as to what we would actually be using this for. And there's more scenarios in this, but C1V1 equals C2V2, and then the second part of that is going to be V2 minus V1 equals your diluent. So my best advice to you is just memorize this so that it's in your brain, you know how to do it. Let's work through how to figure this out. So let's say that the doctor says to make a 1 liter bag of LRS 5% dextrose. Okay? So what we need to figure out first is identify our pieces. So C equals concentration, V equals volume. So let's just start with identifying those. So for C1 is going to be concentration 1. Okay, so we're looking for percentages. We are starting with a 50% dextrose solution. So to convert that to a decimal would be 0.5. So the reason is because on this side you're going to start with what you're starting with, and this is what you want to end up with. So C1 is going to be 0.5 or 50% for the dextrose that we're going to be starting out with using. Okay. Now V1 is asking how much of that 50% solution we're going to need. Well, we don't know, right? That's what we're trying to figure out. So that V1 is going to be X. Now C2 is what we want to end up with. So C2 is going to be 5% dextrose, so 0.05. Volume 2 is also what we want to end up with. What is that? It's a 1 liter or 1,000 mLs. They're both interchangeable. Okay, so we've identified our pieces. Now we just have to plug in the numbers. So let's back up a little bit. So let's write it up here. C1 was 0.5, V1 was X, C2 is 0.05, V2 is 1,000. All right, so let's go through the math. So C1, we'll plug that number in here as 0.5. V1 is X equals 0.05, 1,000. Okay, so we can simplify this side pretty quickly and easily. It's going to be 0.5x equals 0.05 times 1,000, which is going to be 50 mLs, because this is an ml right here. Now this is the only kind of tricky part, is remembering what you do from here. We want to isolate x, so that means we're going to start on this side. So in other words, we're going to divide both sides by 0.5. And that gets rid of this, so we have x equals 50 divided by 0.5, or 100 mLs. So x, which remember was V1. So what did we just answer? We answered that we need 100 mLs of 50% dextrose to make our 5% solution in a 1 liter bag. Now the second part to this problem is V2 minus V1 equals our diluent. So in other words, I can't just take a 1 liter bag, add 100 mLs of dextrose, and be done with it. I need to take out some fluid from the bag. Otherwise, it's going to mess with my percentage. So we already identified volume 2 is 1,000, and volume 1 is 100 mLs. Sorry, that should be 100 down here. So we're going to take 1,000 minus 100, and we get 900 mLs of diluent. So our diluent in this scenario is going to be the fluids that we're administering. So 900 mLs of diluent plus 100 mLs of dextrose. So So in a real life scenario, what we would do is we would take our 1 liter bag, we would grab our sterile syringe, and we would actually take out 100 mils. So you would take this all out, take out your 100 mils, dump that somewhere, and then you would take your dextrose, and we would draw out the 100 mils we needed from this and add it to our fluid bag. And then that's how you would come up with a 5% solution. You could use this same formula for plugging in with just about any number. So if you had a, let's say a 500 ml bag, let's say you had an open bag, or you wanted to make a 3.33% solution in dextrose, it doesn't really matter. You can use it for any scenario, but this is a very common, easy one to do.